Alright, so today we're starting chapter or unit 2. And actually this is, once again as I mentioned before, a little backwards from the book. This is section 1.3. So we're talking about the definitions of right or trigonometric functions with right triangles. So here I want you guys to try these extra practice here. See how it goes, see if you can remember what we were doing from last chapter. Alright, so here are the main things from last chapter. We talked about all of our trig functions on the coordinate plane. We also talked about our reciprocal identities. And so then, if we look here at this triangle with theta, we're going to go back to using our adjacent, opposite, and hypotenuse values instead of x, y, and r, because we're no longer going to focus on just the coordinate plane. So we know sine, cosine, tangent from SOHCAHTOA, or we know this was opposite over hypotenuse, that's adjacent over hypotenuse, and this is opposite over adjacent. Using our reciprocal identities, what would cosecant, secant, cotangent equal? Well, since cosecant is reciprocals of sine, it would be the hypotenuse over opposite. Secant would be hypotenuse over adjacent, and cotangent would be adjacent over opposite. So I'll go ahead now, try to see if you can find the 6 trig ratios for theta here. And I'll give you a hint. First thing you're probably going to need to do is figure out what x will equal there. Also make sure we do want to be good math students, so reduce the fractions if possible. Alright, so now we're getting into cofunctions. Cofunctions, so the trig function of an angle is equal to the cofunction of the complement. Basically what this means is that if two trig functions are cofunctions, then they'll equal each other if the angle measures are complementary. So if we look here as a quick example, in this triangle we know alpha and beta have to add up to 90 degrees because this is a right triangle, 180 degrees total. Take away the 90 from this guy here, leaves you with alpha and beta equaling 90, so they're complementary. If I were to take the sine of alpha and jot it down over here, the sine of alpha is going to equal a over c. Now, sine's cofunction would be cosine, because it has the co in front of the sine. So if I'm looking at cosine of beta should equal the same thing. So cosine of beta would be adjacent over hypotenuse, so that is also a over c. We could keep doing these for all these different functions, which we'll do in class. But the one thing to keep in mind, cosine and sine are cofunctions, tangent and cotangent are cofunctions, cosecant and, hopefully you guess, secant, those are your pairs of cofunctions. So here's, once again, here's all the pairs again for this specific triangle. Here's the cofunction identities. These are in your book. And these are just another way of writing out the cofunction. So sine of theta would equal the cosine of 90 over theta. If you remember 90 minus theta, that's how we were finding a complementary angles. So in this case, theta and its complement, 90 minus theta, sine and its cofunction, cosine. So let's write a couple of these in terms of their cofunction. So the first one, cosine. First thing we gotta do is figure out what its cofunction is. Well, its cofunction is going to be sine. Then we have to find the complement of 30 degrees. So to do that, we're taking 90 minus 30, which should equal the sine of 60. For the second one, for secant, same idea again. So we're going to start with whatever its cofunction is, which is cosecant. And then to find the complement of x, we're taking 90 minus x. There is no simplifying that we can do there, so that is going to be our solution. So lastly, I want you guys to try the third one on your own, see what you come up with for an answer, and then check it with what we do in class. Alright, last but not least, a word problem. I want to get you started on this one. I want you to take a couple, tonight look at it a little bit and see what you come up with, and then compare it with what we do in class. So we have a car that travels 300 yards along the legs of a right triangle. So if we have a car, I know, classy drawing right here. Just wait for it. So there's our car. Travels along the legs of a triangle. So it's going to go a right triangle. So it's going to go out this way. And then the other leg would be here. Because remember, the legs are what's connected by the right angle. And we know theta. So theta is there, and we know the cosine of theta equals 1/2. What we're trying to find here is how far does a bird have to fly? It's flying along the hypotenuse. So we have a bird here. There's its little head. There's its tail feathers. Yeah, that's pretty terrible. So there's our bird, and it's flying along the hypotenuse. Now, keep in mind when it says 300 yards along the legs of the right triangle, it's saying that this total distance that I'm marking in red is 300. And what you're trying to find is what I'm going to mark here in purple. You're trying to find that length for the hypotenuse. So see what you can do to try to figure it out. Also think about this as the cosine of theta equals 1/2. That should help you come up with a special case right triangle that you can use for this problem. So that concludes our notes for today. Hopefully after watching this and then in class tomorrow, it makes perfect sense. Have a good one, guys.